The TI-Nspire is going to make this hypothesis test so easy. Let's go ahead and get started deciding what type of a test this is. So we've got a manager of a large company that sells pet supplies. They want to increase sales by giving these $10 coupons to past customers, hoping that they'll come back in and make another sale. The manager believes that more than 40%, okay, right off the bat, I've got a percentage. So I know that this is going to be a one sample Z test for a population proportion. I'm just going to work in the Scratchpad, and you could certainly work in a document if you wanted. I'm just going to go right to my Scratchpad, and I'm going to look for statistics in my menu. So hitting the menu button, I notice that statistics is number 6. So let's go ahead and hit 6. And I want statistical tests. Those stat tests are number 7. Now these aren't labeled the best, but the ones that say Z-test and T-test, these are of the mean. If we continue to scroll down here, we get to a 1 proportion. That means a single sample. These are our manager's customers. So we've got a 1 proportion Z-test. Let's go ahead and choose this and see what we're looking for. So that 1 proportion Z-test is looking for P0. This is going to be the population proportion, or the proportion from our null hypothesis. We also want the number of successes. This is now in the sample of customers. So the number of successes, X. Those are going to be our return customers, and N is our sample size. And then the alternative hypothesis comes last. So back to our question. Let's start by finding the null and alternative hypothesis. Now these are conjectures about the population, which would be all of the manager's customers. So back to that second sentence, the manager believes that if past customers, these would be all of the past customers, are offered $10 off their next purchase, more than 40%. So we're going to let equals 40%, and that's the proportion P, equals 40% or 0.4 be that null hypothesis. But we're going to try and prove that it's more than 40% with our alternative hypothesis. Let's bring our normal curve here. Now I know that P equals 0.4 is our expected value. So that goes right in the middle. So P equals 0.4, we're going to assume this to be true. This happens to be the P0 or the P sub 0 that we saw in the calculator. We also have a significance level as we're building this normal curve. Down there in the last sentence, part A, it says at the significance level of 0.05. Well, the entire area is 100%. 0.05 is 5% 0.05. That greater than symbol means that we're pointing to the right. I want to be in the upper 5% of all of our sample proportions. Let's talk about those sample numbers next. The calculator asked for X, which is the number of successes, and N, which is our sample size. What it's really getting at here is P hat, the sample proportion. Successes out of total, or X over N. For our sample, we had 90 customers, and of those 90, 38 placed an order. So we've got 38 out of 90. If I do the math there, we get 0.422 or 42.2%. It's definitely more than 40, but I want to know, is it significantly more than 40? Let's put these numbers into our calculator. So I'm still in my proportion test, and I know that P sub 0 now is the population proportion that we're assuming to be true of 0.4. The number of successes, we had 38 customers that placed an order and 90 total in that sample. And then our alternative hypothesis, it was not equals. So I am going to choose from my drop-down menu the greater than symbol, and then, okay. So it gives me these results, which is great. It gives me the Z value. That Z value is the number of standard deviations that our sample proportion, that 42%, is above the mean. So it's 0.43, about half of a standard deviation above the expected 0.4. It also gives me the p-value and p-hat. That p-hat is exactly what we computed, about 42.2%. So how do we decide if we're significantly higher? Well, we've got two different choices. I'm going to first show you the method with z-scores, and then I'm going to show you what I think is the even easier method with the p-value. So for our z-scores, I know that our expected value of 0.4 is 0 standard deviations away from itself. So we're going to go ahead and replace that one with a 0. We also need to know the z-score that cuts off that significant 0.05 or 5% area. In order to find that critical value, let's go back to the TI-Nspire. I again want to click on menu, but this time I want to go to probability. What I'm looking for is my normal distribution, which is a probability distribution. So I'm going to hit number 5 here for probability. And then I want distributions, which is again number 5. And notice that I've got my normal PDF and normal CDF. But what I really want is the inverse normal. The inverse normal will give me a z-score back if I give it an area. So we're going to choose 3 inverse normal, and it's asking me for the area. And the area that the calculator assumes you're giving it is going to be the area from the left. So my area is actually on the right-hand side. So we'll just need to do a quick interpretation when we're done here. So 0.05. And I do want to be on that standard normal curve. Mu, which is my expected value, we are using 0, and then a standard deviation of 1 is the standard normal. Let's go ahead and click on OK. It gives me negative 1.64. I'm going to round that to negative 1.645, which would be on the left-hand side, but I know that mine's on the right-hand side. Thanks to symmetry, I can just take the negative sign off and call this a positive 1.645. So this tells me that the z-score for my sample proportion needs to be higher than 1.645, more than 1.645 standard deviations away from that 0.4 that we were expecting. Well, the test z that we got was 0.43. That's only about half of a standard deviation above. So our sample proportion of 0.422 lives in between 0, that expected value where 0.4 lived, and 1.645. I am not far enough away, so we're going to fail to reject the null hypothesis, which means that that 42.2% is not significantly higher. But wait, I have an easier way for us to interpret that, and that's with p-values. When I'm analyzing p-values, all I need is that alpha equals 0.05. This tells me that my sample proportion needs to be in the upper 5%. So the upper 5% of all possible sample values that we could have gotten. Now it looks like it isn't, but here's an easy way to confirm that using your calculator's results. The p-value on my calculator is 0.333477. That value tells us that we are in the upper about 33.3%, certainly not in the upper 5%, and we again fail to reject the null hypothesis. So what do we tell the manager? We're going to tell the manager that this result is not significant enough to draw a conclusion. Maybe they need to have a bigger sample size, collect more data, or change their marketing strategy. Lots more statistics on your TI-Nspire here.